Right,
Okay.
the recording is on. Welcome everyone to SQL Friday. This is, I think we have SQL Friday number 96. I'm not sure, to be honest. We're close to 100 now at least. But we have Erland Sommarskog, my fellow Swedish SQL user group member and long time MVP, return speaker to SQL Friday. And Erland is going to talk about, you can see it on screen, don't bite off more than you can chew, take it in chunks. I think it's going to be about how fantastic cursors are to use in SQL, something like that. We will see.
Maybe, well, yes and no. There is a relation to cursor, as you will see in the beginning, but oh well. So I guess I should. Yeah, by the way, I don't see the chat. So if there are any questions in the chat, please interrupt me and relay them to me.
I will do. Yes.
All right. So welcome to this session about, well, don't bite off more than you can chew. Take it in chunks. Now, yes, Magnus talked about cursors and loops, etc. So there might have been a time way back then, you were a very young junior SQL developer. You looked at a senior colleague and said, I got this table. I need to loop over that. How do I do that? And your senior colleague looked at you and smiled and said, no. In SQL, you don't write loops. You work with set-based statements. You work with all data at once. And as you progress with SQL, you come to learn those set-based statements. You come to love them. They became your way of life. But then every once in a while, you might have encountered some really big data set. You might have said to yourself, should I really work with all data at once? And maybe you should not. Maybe you should take it in chunks. So, let's see here. I have two screens here, and my problem is the one is moving from one screen over to the other one. There it is. Yeah. So sorry about that. So my name is Erland Sommarskog, and I live in Stockholm, where I work as an independent consultant, and I've been MVP for SQL Server for many years. Now, if you want to get a hold of me, get in touch with me, you do that by old-fashioned email, sql@sommarskog.se. And also I maintain a website, Sommarskog, and I should say that you're more than welcome to drop me a line if you have any questions related to this session or anything else about SQL. So I also maintain a website, sommarskog.se, which you can see as a small collection of large articles that goes in depth in a couple of topics. However, there is no article about chunking. There's only presentation that I have. But on my website, though, you find on sommarskog.se/present, you find the slides and scripts for this presentation, and you will see this link at the end as well. So this is my agenda. I will start to talk about two scenarios when chunking might come into play. Here with some cryptic subtitles. Don't bite off more than you can chew and be nice to others. Then I will go on and talk about how to implement chunkings. I will talk about performance and pitfalls and things you need to think about, and that will be the main meat of the session. And the last thing I will talk about is one more scenario where chunking comes into play, and that is using chunking for error handling. And here with the cryptic subtitle, when all or nothing is not what you want. So say this. You have a table and you want to perform an operation on that entire table, or at least the better part of it. So for instance, you realize that int column there, your surrogate key, wait a minute, our business is growing, we will need big int. And of course, you can do that with all the table. But you may also prefer that, no, I create a new version of the table and copy over all the data. Or you might have added a new column to that table, and now you want to initialize it with some values taken them from other tables or whatever. So you want to update all rows for that column. Or you might want to do a purge that get rid of, let's say, 50% or 90% of the rows, or for that matter, all of them. And in that case, you might get away with truncate table. Now, anyway, say that this table is 300 gigabytes in size. So what would happen if you would really work with all data at once? Hey, it may be a lucky day and everything may go just fine. But much more likely, though, is that the transaction will start to grow violently, and the DBA comes rushing out from his cubicle or wherever it's sitting and saying, what is going on? What's happening to my server? Also, the temp to be, both the data file and the log file, may also go out of bounds. Maybe not now, because on the previous slide, I gave you some very simple operations, but your operation may be a little more advanced, so you might fill up temp tables, or you might be in the plans, be spool operators and everything else that uses disk, and it just also goes away. It just explodes and the disk fills up, etc. There can also be an issue with the memory. So let's say that you need to read this big table, and the table is bigger than you have RAM. So if you're going to read it just once, it's not really a problem. You're going to read some rows, and then we're going to read the remaining rows, they will fall out of the cache, etc. But let's say for some reason you need to come back to one row and read it many times, and every time you need to read it from disk. Well, that is not going to be fast. Also, one issue to consider is that if for some reason the operation has to be cancelled, well, the rollback can take a very long time. Now, the remedy for all of these problems is to split up the works in chunks. So rather than working with all data at once, now you're not going to write a loop and take one row at a time, as you thought when you were a junior, but you're going to work with sizable subsets of the data at the time. And of course, the chunk size should be small enough so you don't get this problem with the log file attempt to be and all the other issues. But also, you should not make the chunk size too small, because the chunking will have overhead and the bigger chunks are more efficient until you hit one of these limits. Now, of course, now you can ask me, so what is the right size? How many rows should I have in my chunks? And you already know the answer. It depends. It depends on a whole lot of things. For instance, what is the current size of the log file attempt to be? I mean, let's say you already have a 10 terabyte log file. Well, then maybe the log file is not an issue. And also, what growth do you permit for these files? But it's not only, because also don't think of the number of rows, because you also have to think of the row size. Now let's say this, you have only 1 million rows in that table, but there is a lob column in that table, and you need to operate on that lob column, and the average size of that lob column is 1 megabyte. You are looking at a 1 terabyte table. You probably need to take that one in chunks. But all this said, I have a kind of a standard value, which is 5 million rows. And this is not completely taken out of thin air. A couple of years back, I was working with a client and I had a table, no lob columns, but it was, well, like 40 to 50 columns. It was not extremely narrow. And I was working with a change script that actually is one that my tool generated for me, but I want to find out what is the optimal chunk size. And I found that when going from 500,000 rows to 5 million rows, I still gained performance, well, let's say 10, 15%. I actually stopped at 5 million rows there, but so it actually can help. That is a difference between 500,000 and 5 million rows. But as they say, your mileage may vary. There's many things you need to take into account. Now, you also need to think about the transaction log. Just because you split up the things in chunks, that doesn't mean you can forget about the transaction log, because we talk about very large operations here. So you will produce a lot of transaction log. Now, if you can put the database in simple recovery, you might be able to forget about the transaction log. But that is very, very rarely feasible in production. For instance, if you have an AG, there's no way you have to be in full recovery. So if you are in full recovery, you may have to think about increasing the backup frequency, because if, let's say, the normal backup frequency is only every 15 minutes, you might explode the log in those 15 minutes. So think about that. Then they might say, well, rather than changing the scheduler, I'm going to add a backup log to my chunking script. I don't think this is a good idea. If you do it, you should have the same name and place and name convention as the schedule log backup, because else normal restore procedures are going to fail if you actually need to do a restore, which could be because there is corruption, etc. Now, be nice to others. This is a different scenario from the previous one. On the previous scenario, I more or less assumed that you had at least a database and maybe the entire server for yourself. Now, this case, we're actually talking about an operation that is smaller, maybe only 5 million rows in total. However, this is something that is going to occur in a live system. Maybe it's part of the application. So now you have to think about, you could affect, if you try to do all these 5 million rows at once, you will take up too much resources, CPU, memory, etc. And also, there could be lots of blocking and deadlocks. So again, the remedy is to split up the work in chunks, now with a fairly small chunk size, which means that, yes, your operation will be less efficient. However, the overall system health will certainly benefit from doing this. And in this particular case, there is a kind of a limit that you may want to have to look at. Not always, doesn't always apply, because it depends exactly on the nature of the problem. But that is, you may want to avoid log escalation. Let's say that you're writing a purge operation that's going to delete very old rows and kind of. So you're going to work here on the left side of the table. And the users, they're mainly working here on the right side of the table. So you don't want to interfere with these users. So you want to avoid the log escalation, because you might know that when a SQL server have more than 5,000 logs in a query, it tries to escalate to table level, and you want to avoid that. So that means you must stay below that number. Now, so in order to avoid this, I would recommend you that you run a test operation with different chunk sizes inside the transaction and have a look at your logs. And we're going to have a look at this in practice. So here I've got a database called BigDB, which is the database for today's session. And I have a table here called big trans. I would come back to that one later on. And here I'm saying, okay, delete 2,500 rows. And I'm looking here in this dmtralogs. I'm looking at the resource type. So what kind of thing am I looking? Is it a table, a key, whatever? What way am I locking it? The ID for it, and that could be a table ID. So I'm also then trying to translate the name. And how many of these logs do I have for my current session? So let's see what happens when I run this. Well, first of all, I got a share log on the entire database, which is perfectly normal. Then I got key logs on 2 different indexes, and these are key logs, and these are row logs. And you can see I got 2,500 of these. So this is good. This means that I'm not blocking users that are working on the other side of the table, hopefully. But then you might also see here, I got also a log on table level, but that is an intent log. An intent log is a log which basically means, hey, I'm down here doing work. So in order to take a log on a row, the SQL Server first has to take a log on the object and then on the table. But these intent logs, they should not be an issue unless a process wants to take a share log on the entire table. But then those are difficult. Those conflicts are difficult to avoid. But these, you're doing your part with this scenario. But let's now see what happens if I increase this to, let's say, 3,000. And now I only have 2 logs, one on the database, and one big single fat exclusive log on the table. So this one is too much. And the key takeaway here is that because there are 2 indexes on this table, we get in total 5,000 logs. So let's say you have 4 indexes on the table and a clustered, 4 non-clustered index and clustered index. Then maybe your chunk size cannot be more than 1,000. But as I say, you should test this. So just to repeat this, you should see X logs only on key and read resources. Read is also a row log. That is when you have a heap. You get those. If you see X logs on object or page, that means that the chunk size is too big, or well, at least if you see them object level, you won't get. You never log escalation never goes to page. So if you see have X logs on page, this probably suggests that maybe your index is not very good, so you need to improve that. So there's probably some scan going on. But the intent logs, the IX logs, etc., on object and page, they are okay because they're only indicating you're down there somewhere. All right, now let's talk about the challenges with implementing chunking. It's not that chunking is like a really wild adventure, like going on a multi-day hike. You need overnight equipment, you need food, you need maybe emergency connections and all that sort of stuff. You need to prepare a whole lot. No. But it's not a really walk in the park either. It's like, you could say it's like taking a forest walk. You need some sturdy shoes because maybe you have to negotiate a stream or two. You could slip on a stone, you could trip on a branch, etc. So there are some traps you can walk into. First of all, you need to write more code. And that means that there's more code that can have bugs. And there's more code you need to test. That is just where things are. And you need to think about how is the application affected. And what if the work is interrupted halfway through? How to deal with this situation? And most of all, performance. Because if you do your chunking the wrong way, your performance can be so bad that it would have been better if you hadn't done chunking at all. And in the coming slides, I will cover these topics more or less in the reverse order that I have them here. So let's start with performance. So here's a chunking operation, and there's the question, is this a good chunking operation or not? So the scenario is this: I have some big table and I've added a column, new column, that I want to initialize with something, but maybe query from other tables or whatever. And I'm saying, okay, I got to set my chunk size to 5 million rows. And as long as my row count is equal to the chunk size, I'll say, okay, update top chunk size, set new column when new column is not. And then I capture the row count and keep looping. Now, is this a good operation or not? And the answer is no, it is not a good operation. On the first iteration, well, SQL Server will quickly find 5 million rows and update those. On the next one, well, okay, here are 5 million rows when new column is not null. Okay, here are 5 million more rows. And next time it has to go through 10 million rows, etc. Let's say that in total there are 500 million rows in this table. So that's 100 chunks. That is equal to, so this loop is equal to 50 table scans on this monster table. No, that is not good. When you do chunking, indexing is critical. You must always define your chunks to run over an index column, because else you will repeating scans over and over again. They're all classic reasons why loops are slow, often because you repeat the scan. And so this is not going to be good at all. And I would also say this: the larger your chunk size is, the more imperative it is to use the clustered index. Because let's say you have a chunk size of 5 million rows, and you think, I'm going to use the non-clustered index, and the optimizer looks at this and says, what? 5 million kilocubs? Me? No, I'm going to scan that table. So, but if you have smaller chunk sizes, then you might, non-clustered index may work. But again, 5 million kiloocups is 5 million kiloocups. But I need to qualify this as a little bit. Sometimes there might be business logic that mandates that you take the rows in a certain order, or there can also be joins to other tables that may affect your choice of index. And we're going to see an example of this later on. Now, this table, big trans, this is something I got from a blog post by Adam Mechanic, that we had set up to be a big table to be a demo table. It's 2.2 gigabytes in size and 31 million rows. But for real world, there were days I might have thought, oh, 2 gigabytes, so that's a really big table. I don't think that these days it's, well, maybe not a small table, but it's certainly not big. And for real life. Anyway, there are 5 columns, and I want to change most of these. There's a transaction ID, which is integer, but I think my business is going to grow, so I want bigger. Then I got a product ID, which is a foreign key. There's some transaction data, quantity, and amount, and these as funky data types, and also they're nullable. So this is what I want to change them to. And also this table has a non-clustered index with product ID, transaction data, including amount and quantity. Now, so if I want to make these changes, I could do that with all the table, of course, but first of all, I need to drop the primary key and the non-clustered index and recreate them at the end. I then need to run 4 alter table, alter column statements, all rebuilding the table. So this, when I try this, well, the total time was 984 seconds and the transaction log grew by 20 gigabytes, and I started with a 700 megabyte transaction log. So then I said, maybe I should create a new table. So I created a new trans with a clustered index in place, but not the foreign key and the non-clustered index initially. Then I copied all the rows in a single insert statement, and then I created the foreign key and non-clustered index because I found that this was a faster way to do it. And now it took only 68 seconds, but I still got the transaction log growth, however, of 7 gigabytes. Now let's see if we can improve this further by doing chunking. So I'd like to introduce you to a generic way to drive chunks. And now, the top line here is, this is not really part of the best practice. As you see here, I got a store procedure and have a chunk size as the parameter. This is because I ran tons of tests to get some interesting data for this session. And to do that, it was practical to have it packaged in store procedures and have the chunk size as a parameter. But for this kind of thing, like a one-off table, changing a table, you would probably not have a store procedure and you would hard code the chunk size, and that's all right. But the rest of it is part of the pattern though. So min ID and max ID, those are my chunk boundaries. And I initialize getting the first lower boundary by taking the lowest transaction ID in my table. Then I keep on looping as long as this one is not null. Then I have this subquery here. I say, okay, give me top chunk size transaction ID from big trans, where transaction ID is greater or equal to my lower boundary and order by transaction ID ascending. Then I say, okay, give me the max value of these. So then I have my upper boundary. And then I copy the rows, insert from big trans, select from big trans, where transaction ID between these two. And then I get my next lower boundary by saying, okay, min ID is less than, equal to the smallest transaction ID, where transaction ID is greater to the upper boundary. And then I just keep on looping, and then we'll get back null, and then I'm done. And the last thing I do is to recreate the non-clustered index and the foreign key. Now, before I move on and look at the data, I like to dwell on this pattern a little bit. So in this case, we're looking at integer keys, but this pattern works with any data type you can put an index on. It works with strings, it works with dates, it even works with floats or grids. It even works with multi-column keys to some extent, and we're going to come back to that later on. So this is a very generic pattern to use that I would recommend. Now, so what data did I get? Well, first of all, I like to remind you that at the times you see includes restoring the foreign key and the non-clustered index, which a little bit dwarfs the relation between the chunk sizes, but I wanted to look at the full use case. Now you can see here that for the smallest chunk sizes, there was really a penalty for these. It was quite a bit slower. When it comes to the transaction log, well, up to 1 million rows, I did not get in the log transaction log growth, except for the smallest chunk size for some reason. But for 6 million rows, yeah, the transaction log started to grow. And when it comes to the execution times, well, so 1 million rows seems to be a sweet spot, although it's not extremely convincing. 1 second, give or take, that could be general flutter, but at least these seems to be, and it makes kind of sense. Because I said, the smaller, the bigger your chunk size, the more efficient they are until, like, for something starts to happen. For example, the transaction log starting to grow. Now, I like to remind you that this table is only 2 gigabytes in production. If you're in a real world scenario, you wouldn't dream of doing chunking over this table. And also should also say data. This is I did run this on my laptop. So if you try this on your big evil server, you might get slightly different results. Now you might think here, but wasn't that overly complicated with that top? I mean, what if the IDs are contiguous? And indeed they are in this table. Could we just simply do this? Select max ID equals min ID plus chunk size minus 1. Well, I did test this as well. And here's something quite interesting. Well, first of all, if I got a bigger chunk size, yes, I did gain some performance, like 5–10%. But for the smallest chunk size, this pattern was actually slower. Don't ask me why. But the more important thing is that, well, let's say that there happen to be gaps in this table. Then all of a sudden you could get a chunk with 3 rows in it. That's stupid. So that's why the other pattern is a lot better, because you don't have any issues with gaps. Now, there are some things you need to think about when it comes to optimization. So the way I wrote this, the min ID and max ID, they are local variables, and therefore the optimizer has no clue about the values, and it will make a blind guess. 9%, it will think. And let's now say you actually also join into other tables, you can get quite performance hit because you get a bad plan. This happened to me a couple of years back. I had a table that I wanted to add some more columns to, and taking the values from other tables. So I composed an update script, and I had no problem because in my test environment, I had 30,000 rows. But eventually, when my client took it to their customers, well, at one side it took 12 hours, and another side they gave up after 24 hours. And they contacted me and said, oh yeah, that wasn't very good. And I wasn't working very much with that client, so I didn't really have the time to think about it. But before I came around to look at it, another guy there who's a really smart guy, I worked with him for many years, he said, try option recompile. Boom, that was it. Because now the optimizer knew exactly, or knew the intervals, and could therefore say, okay, yeah, it's that many million rows, and it could make a lot better choice of plans. And I think it took like 20 minutes, whatever it was, at the biggest customer, which was perfectly adequate for the situation. Now, there is a potential problem with option recompile, because there is a recompile for every iteration. Now, with the chunks, there's a 5 million rows, and let's say each chunk, let's say they take 1 second to process, and it takes, let's say, 10 milliseconds to compile. That is not a problem. But let's now say instead that you have a chunk size of 1,000, and that takes, well, let's say 10 milliseconds to process and 10 milliseconds to compile. Then option recompile will add quite a bit of overhead. But there is a second solution. You can make the chunk boundary nouns by making the parameters to an inner scope, which, for example, could be an inner stop procedure, but it doesn't have to be a stop procedure. You can simply do this. You can wrap the whole thing in SPQ to SQL. So what I've done here is there's nothing dynamic here, except that now these are parameters, and the optimizer can sniff the input values and then make a plan that they can cache and reuse, and hopefully that will be good for the full iteration. Now, you might be saying to yourself, yeah, but this case is a complete overkill, because this statement is so simple. It's the clustered index. It's a trivial plan. Nothing can go wrong here. Yeah, I thought so too. But look here at these numbers. I got a drastic improvement by introducing dynamic SQL. I slashed for this chunk size. I slashed the execution time with a factor of 3. I don't understand what is going on, because there's nothing visible in the plan, but I did it. Also, option recompile. Because of the overhead, I did not get that particular gain. And actually for 5,000, it was even slower than not doing nothing at all. And then I got a small problem here, because this is not recompilation overhead. I mean, for this chunk size, for example, there is only 7 chunks in total. So it turns out when I looked at the plan, in this case, there is a small difference, and apparently that optimization backfires. Yeah, those things happen. Now, I should also say this. This was the data I got originally when I ran these tests on SQL 2016, and that was in early 2019. Then, like in the autumn of 2020, I ran new tests because I did this session in the past. I wanted to have fresh data, and I also ran it on SQL 2019. And on both versions, I did not actually get these exactly starting numbers, but it was still a difference, quite significant. I think this number was now 145. So sorry, seconds. Excuse me. Oops. Excuse me. One of the problems, or one of the risks of going to a conference in Seattle like past, is that you can easily get a cold or so. That has happened to me more than once. But I still kept these numbers because it's just so completely drastic effect. Now we're going to look at a different operation. So In this case, I got two tables, one called big orders and one called big details. And to the big orders table, I have added a column called total amount, which I need to initialize also with values from big details. And you can see here, big orders, 5.1 million rows, 1 gigabyte in size. This one is 50 million rows and 3.8 gigabytes in size. Now, so what is interesting with this one is when I looked at this, I got some surprise. I found that for the smaller chunk sizes, dynamic SQL was actually slower. I scratched my head, but eventually I found the solution. The reason is that big orders has sample statistics. Big trans has full scan statistics, but this one has sample statistics, and the lowest ID in the histogram is 30,063. This means that for these two chunk sizes, the first chunk is entirely outside of the histogram, and the optimizer thinks, oh, one row, and creates a plan for one row, which is not, of course, not the best one. Sorry. Oh, sorry. This is going to be. You might that might be the last cough of this session. I'm sorry about that. Anyway, so don't laugh at me. So therefore the plan is not good for these rows. But once I get a bigger chunk size so that the first chunk is inside the histogram, I get a better performance. Now, the remedy for this situation, we could do this, is to update statistics with full scan, but only on the index we are actually using. Because if you say update statistics table with full scan, it's going to update for all statistics. And that means for all columns that are not indexed, that's a full table scan for each column. That can take a very long time. Even this may not always be feasible, but at least it could be. And the times you see here includes the update statistics operation. So, and you can see they are quite much in par. Although actually they're slightly slower though, but that is because of this operation. But again, this is your mileage may vary. Now, and now I'd like to point out, why do we actually use dynamic SQL or optional recompile? It's not to get slight last 10% performance, but look here now. So this is the same operation, but now this time with the big orders table, I put the clustered index on the custom ID. And look now, if I don't have nothing at all, no recompile, option recompile, no dynamic SQL, and just also for the sake of it, just imagine that these times are minutes rather than seconds. And let's say that this chunk says actually, well, let's say 1 million rows, and that is actually what I can work with. Well, it's a complete disaster. It's 3 days, more than 3 days. Whereas with dynamic SQL, well, okay, 96 or 127 minutes. Well, that may not vary. So that is the whole thing. They are a protection against complete disasters. So that's why you should make these safeguards. Also interesting here, we can note here that in this case over order ID, this is now this chunking is done over order ID, so that's the non-clustered index. And you can see that actually give slightly better performance. So in this case, because I'm joined into the big orders table, which has a clustered index on order ID. So that's what I'm talking about recently, that sometimes the rest of the query might determine which is the best column to loop over. Now let's talk about multi-column key. So the big details table has a primary key on order ID and product ID, and that can be up to 600 products per order. So how will we deal with that? I mean, let's say if we want to do an operation on that entire table. Well, just ignore the product ID and run a top loop over order ID? Yeah, I mean, of course. Let's say we got a chunk size of 5 million rows or even 50,000 rows. Some chunks might have 600 rows extra. Well, who cares? And believe me, you want to stick to this pattern as long as you can. But obviously, though, let's say that there can be up to 10,000 products per order, and you cannot exceed a chunk size of 1,000 because of log escalation. You need to be nice to others. Well, obviously, then you need something else. Well, then you might say to yourself, I can just extend that top loop to use 2 or more keys. Yeah, maybe, or maybe not. So a warning here, this might go a little too fast for some of you, but there is kind of a point with that. So anyway, this is update price simple. It is the same pattern as before, so I go for the smallest order ID and big details. So here I'm ignoring the product ID, and I'm saying, hey, max ID is equal max order ID from chunk size. For the order ID is greater than equal min ID, etc. I do my operation of this kind is really silly one. I'm multiplying the unit price by a factor of 1.2, and I got an option recompile here, and I keep up looping, and so I'm completely ignoring the product. But now let's say I want to make sure that I stick to chunk size exactly. So I got the update price double, I got the min order, and you can see I got a lot more variable. I got the variables. I got a min order ID, a min product ID, a max order ID, and a max product ID, and also stop order and a stop product ID, and the game over. So I start with getting my lower boundaries, and I can't use min anymore because, of course, I don't want the smallest order ID and the smallest product ID. I want the smallest order ID and the smallest product ID on that order. I also need to get the last one. That's why I get the stop one here, and then start my loop, and I'm initializing these max order ID and max product ID to null. And then again, I run my top query here, select top chunk size from big details, where order ID is equal to the lower boundary, or product ID is greater or equal to my lower boundary, or order ID is greater for the remaining orders. And the idea is now I want to have the max value, but again, I can't use max, but I'm using row number. So I'm saying here, okay, well, row number is equal to chunk size. That's my max order ID and max product ID. That is my upper boundaries. However, for the last chunk, I will not get, most likely, rather, I should say, I will not get back chunk size rows. And when you know this, when you have a select statement where you assign variables and it doesn't hit in rows, that does not set the variables to null. It just leaves them unchanged. And that is why I had to set them to null up here. Now, if I found that max order ID is null, this means that, okay, it's game over. And I will set max order ID to the top ones that I determined in the beginning. Now we're going to do the update. I need to consider a few things. First of all, did I move to a new order or not? And if I did, well, I need to take all the remaining products of that order, and I take the first couple of products on the last order and all the orders in between, and combining this with this OR condition. And but it could also be that I'm staying within the same order and just saying, okay, this range of products in that order. And if it's not game over, I will finally go and find the next lower boundary the lower boundary for the next chunk, what I'm doing with this select top query. Now, when I tested this, I found that performance, particularly for the smaller chunk sizes, was not fantastic. It was quite poor. And when investigating it, I found that the reason was exactly this update statement, because the OR condition often causes a problem for the optimizer. I think it introduced some kind of Halloween protection here. So I found that to get better speed, I need to do update price triple, which is more or less the same, except that I now have 3 update statements for all the 3 cases here. And now I got performance that was quite close to what I get with update price simple. Now, you might, as I said, this might have been a little bit too fast for you, but there is kind of a point with that, because I don't like this solution. I think it's very complex. And this was only 2 keys. Imagine doing this with 3 or 4 keys. So you might have to do this, but it's not trivial, and you can easily get things wrong. So I like to look for alternatives. And here is a fairly simple-minded solution where I define chunks in the temp table. I got a table here called hash chunks with an order ID, product ID, and a chunk number. And I got a clustered index with a chunk number as the leading column. And I'm filling up by saying getting all the IDs from the table and using row number with integer division to compute the chunk size. And then I set up a cursor and going to take all the chunk numbers I have in my temp table and keep on looping as long as I get a chunk number back. And then I do my update. So I'm saying update big details where exists from chunks where chunk numbers equal to chunk now, and mapping on the order ID and product ID. Now, note here how the clustered index is set up. The chunk number is the leading column, and then order ID product ID follows the primary key of the table. And same is done when I define the chunk numbers. So this means that this here is now addressing an adjacent set of rows in big details. And that's important because there are optimizations for this case. I also made a test where I set up the chunks in such a way that the rows were scattered all over the table. And this ran with I think it was like 4 or 5 times slower. So this is quite important to do it this way. So again, each chunk has a contiguous set of keys for an efficient join. And compared to the triple top loop, well, it was slower, of course. In best case, only 1.3 times slower. In worst case, 5.6 times slower. I think in that case, it was probably not the best plan for that particular chunk size. And I would say, if you try this with your table, you might quite different results, because I think the profile of the table is going to matter a whole lot. And absolutely no discussion here. We are sacrificing efficiency for simplicity. Because keep in mind, these would typically be one-off operations that you don't want to spend a whole lot of time on testing on. Now, this was the big temp table, but we also have the small temp table. And the big temp table has many rows as the actual table, but it's narrow because it only has the key values. And it requires a full scan to fill, but could block writers in some situations. That alone can be a problem. And of course, the temp table is still going to be big. So this is not always a good solution, but I still think it's a viable technique because it's simple. But we have a small temp table which you fill one chunk at a time. It's more complex, but I still prefer this one over the complex top loop. So here I got again some variables, and they got slightly different names because they have slightly different functions. So core order ID, last port ID, and also row count, which is initialized to chunk size. I got a temp table now with only order ID and product ID, and I initialize the core order ID to the smallest order ID -1. It's important it must be a number which is lower than the lowest value that I have in my table. And I keep on looping as long as my row count is equal to the chunk size. I start with initializing all my variables that I need in the loop. In this case, that is the temp table. That is, of course, I can do that at the end, but I always prefer to initiate loop variables, things like that in the beginning. Then I fill it up with a top query. So give me all orders on the current order ID and the products that are greater than last product ID, and also the remaining orders. And again, it's a top query, so I will get a full chunk here. And I capture the row count, so the last chunk will have less than chunk size rows, most likely. And then I do my update, and again, it's a contiguous set of rows. And then I get what was the upper boundary for this chunk. So that is the meaning of current order ID and last product ID. It's the upper boundary I use. You can see I used order ID descended and product ID descended. Now, compared to the tripod top loop, it was still slower, but up in worst case 3.4 times slower. Although again, it might be a query plan issue, which I could have maybe fixed with a hint or something like that. And compared to the big temp table, it was up to 5 times faster. Here's a link to the same script again. If you look at it, I'm not going to open it again, but this script has a full version of the small and big temp table. It also has a version where I got the scattered temp table, and there's some variations with dynamic SQL, etc. And there is also some results from my tests in performance. Now let's leave performance behind and talk about the impact on the application. If you don't do chunking at all, everything is one transaction, which means that the application and the users will see all or nothing. But if you introduce chunking, well, how will the application behave if data is just processed halfway through? How will users think about that? Well, it's even more pronounced if the operation is interrupted, either because there was an accident or because you only schedule it to run certain hours per day. And maybe you can shrug your shoulders and say, it's not a problem. Nothing, there will be no issues at all. Or you might have to make substantial changes in the application. I can't say, you have to think about this for yourself, but one hint is that if you already have an operation in place and you're thinking maybe we should do this in chunks because it's actually getting a bit of a pain with this, quite likely that you need to think about how what that could affect the application. Now let's talk about resuming chunking. Your chunking operation is running and for some reason it stops, either because there was an accident, the server crashes, or maybe because you have scheduled it to only run, let's say, between 2 and 3 o'clock in the morning, because that's the only time you can permit this thing to be running. So we're going to look at 4 canonical examples, 4 canonical operations to see how what strategies we can apply. So first of all, we got a purge operation here. I'm setting in the purge state and chunk size, and I want to delete all rows that are older than purge state. Now, as you may or may not recall, there is no column, there is no index on big trans with transaction date as the leading column. So to avoid doing scanning again, what I do is I'm doing a scan here now. So I'm getting all the rows that are related to purge date and number them and do integer division with its size to get a chunk number. But I don't materialize that in the table. I just say, okay, for each of these chunks, give me the smallest and biggest transaction ID, so I get my chunks. And then I'm looping over this cursor, and the delete operation itself is very simple. Now, let's now say this operation is for some reason stops by schedule or whatever. Now, how do I deal with how to restart this? Well, that's trivial. What has been deleted has been deleted. I can just start over. Now, then we have this insert operation. I'm copying rows from big trans to new trans. Now, in this case, if I try to it crashes, and if I try to restart, is that going to work out? Of course not, because it's going to try to start from the beginning, so it will die immediately with a primary key violation. But that's very easy to fix. So here's insert top restart. Rather than just saying min transaction ID from big trans, I'm saying, okay, give me the maximum transaction ID in new trans added 1, and that's my lower boundary. So that's very simple to start. I could find something in my operation to define where I'm going to restart. Here I got update absolute. So this is again the scenario. I have added a new column to a table, or more precisely, I'm doing an absolute update. That is, I'm setting the column to something which is not depending on the current value of the row. So, and I'm running, well, again, the standard top loop, get my lower boundary, get my upper boundary, and this time I'm using the dynamic SQL. I'm setting new call to some value. Now, if this one stops, there's no problem with restarting in terms of logic. You will get the same result. However, of course, I'm going to redo work. I can do it slightly better by coming out this row here. A new call is null, but I will still go through all these chunks. So it might be better than to do this one. I start with getting a min ID rather than just saying min or ID. I say when new call is null. So I find my starting point and do that one instead. Now then we get update price simple again. This is a relative update. That is, I'm multiplying the unit price by itself. Now, what if this one crashes halfway through? How do we resolve this problem? Think of that for a second while I get some water. Well, unless there is something very, very magic about these prices, there's only one choice. Restore back up and start over. And that's not fun. You don't want to go there. That's absolutely not what you want to do. So we need to think of something better here. So here's update price resumable. And what I'm doing here, when I'm entering it for the first time, I'm checking, do I have this table called guest.last ID? And if not, I'm going to create it. And it's one column, one row table. And I'm going to add to that the smallest order ID -1. And when I come out here, I just pick up min ID as last ID +1 from this table. And then I do my looping again with one extra statement in the transaction. For each loop, I'm updating with the upper boundary of my batch. So if this one now crashes, I'm going to come back here. I will not do this one, but I'm going to start here, and I can start where I was and keep on doing. And at the end, I'm going to drop that table. Now, you might be thinking, what is this guest dot? Well, you know about the guest user, and the guest user always has a schema, and you can't get rid of that schema. So I'm thinking this is a kind of a temporary table, so I'd want to keep it out of DBO, so I'm putting it in guest, but I might be too fancy. You don't have to do that. What is important, though, is that it has to be in the database itself. It must not be in temp2b because it must survive server restarts. So that's the key takeaway. Now, let's think about this pattern and going back to some of the other procedures. So if we take this one, update price absolute, let's now say I'm initiating this new column, but I can only do this between, well, 2 and 3 o'clock in the morning, and it will take several days to get through because it's a really big table. And maybe then if I do this, I have to spend 5 minutes of looping to find this min already. That's kind of a waste of time. If I instead use this pattern by having this table, I can spend 5 more minutes updating. And maybe then I can complete in, let's say, 8 days rather than, well, 9 days, something like that. And if we take this purge operation, well, I'm going to do this scan every time I restart. So what if I actually materialize these values into a table? And then I got values in these tables. I'm not going to even run this one until I've exhausted that table. Then maybe I'm going to run it again because maybe the data has changed. So I'm going to purge more rows. So I just wanted to point out that this pattern of having a table which defines where to restart can be useful in many occasions. So what strategies we can assume for resuming chunking? So the simple most one is just ignore and start over, and works well with purchase and also with absolute updates, but in that case you will redo work. That could be cases where you can use logic of your operation to find out where you were. For instance, finding the last row you inserted, or you can add a help table to track where you are, but not in temp2b. It must survive server restarts. And, well, if you haven't planned at all and that you don't need to know what's going on, well, you have to restore back up. And I like to point out that, I mean, these were very simple operations, but let's say you're running a loop and maybe there's just a procedure that is doing the work for you, and you don't really know what that is doing. So the more complex the operation you are, the less certain you might be that you can just restart. So you might have to go restore back up. And as I said, you don't want to go there, but you need to plan ahead. Now, there is actually one more option that might shock you a little bit. But what if I do that chunking inside a transaction? Then it's not a problem, because if the operation fails, it's going to roll back. Obviously, this doesn't work with plan resume. But wait a minute. Didn't we introduce chunking to avoid issues with transaction? Look, this is completely crazy. Yes. But there is one more reason to do chunking that I haven't mentioned yet. The issue could be that you have a query plan where the performance doesn't simply grow very linearly. So let's say this, 1,000 rows takes 50 milliseconds, 10,000 rows takes 2 seconds, 100,000 rows takes 40 seconds, etc. So, or you have, it grows linearly to some point, but then it starts to spill to disk and performance just goes crazy. And the best, of course, might be to address that query, but for one reason or another, it may not be feasible. So therefore, you could do chunking inside the transaction. This may still seem very far-fetched to you, but I have encountered this. I ran into this situation. The customer was running very large operation to levy custody fees, whatever it was, and they were sending it. So, and that procedure sent in 140 transactions, 140,000 transactions to general procedures we have to book transactions. Inside that procedure, which we had used for quite a few years, there was a loop between two table variables. And yes, that query plan was not growing linearly, no. And because that procedure has used so many parts of the system, actually, we hadn't seen this problem before. I didn't really feel like changing it when I tried to recompile it, see if I get small chunk. No, it didn't work out. So what I did was, in that outer procedure, I simply sent in inside that transaction in chunks of 10,000 rows rather than sending in all 130,000 at once. And also because removing that transaction split and so the chunking would have been exposed to the application, and that would have been a huge impact. That would have created a whole bunch of new problems to solve, which I didn't want to do. Now let's also talk about the risk for bugs. I mean, okay, it's not that chunking is extremely difficult, but still, if you're kind of coding casually, sleep at your keyboard like this, so then you can do silly bugs like, well, skipping a row between chunks, or process the same row in two chunks, or just miss the last few rows. So I would recommend you this, that you test on a small data set with different chunk sizes. Sorry. Sorry. Different chunk sizes. So the last chunk fold -1, last chunk exactly fold, last chunk exactly 1 row. Of course, I have already given you a pattern you follow. So of course, that has been tested. But I know you will deviate from that pattern every once in a while because it will make sense for the exact problem that you have at hand. Review your code, have someone else to review your code, and if possible, add assertions. I mean, for example, if you're copying rows from one table to another, you can check the row count. You also need to test for performance, and this is a challenge because you cannot just test all variations because it just takes too much time. I know because I ran loads of tests for this one, and because to make sure that the testings are valid, I had to restore the backup every time. And imagine that you have a 10 terabyte database, so you're going to do this. Yes, only the resource is going to take too much time. So you're more or less going to have to make a choice from gut feeling, but you need to test that gut feeling so you know that it's not a disaster. And keep in mind, because you are not looking for the top performance, you often don't care if it takes 1 hour or 50 minutes. What you want to do is to stay away of clear of disasters. You want to know that it takes the time you have to do this operation. And also keep in mind, you should not only look at the execution time, you should also monitor the log space and temp-db consumption so you don't get these accidents. And I like to put in some general performance test caveats. So first of all, test the copy of reduction database or equivalent. Sometimes this can be a challenge if there is very sensitive data with GDPR and PI, etc. Maybe it has to be anonymized, etc. But if you have some made-up database that doesn't really match productions, the risk for surprises when you do it in production can be, well, bigger than 0. And make sure that you have the same settings. If you're going to run with full database, full recovery and production, do that in test as well. Snapshot. And if you have snapshot enabled in production, also have that in test. And keep in mind that if you have, even if you have not enabled read commit or snapshot or anything like that, but you have an AG with a readable secondary, you still have some of the overhead that you get with snapshot isolation. If you have accelerated database recovery enabled, of course, you should have that in test as well. The hardware should be matching or worse, but it should not be better. Although I recommend that if possible, make sure the RAM is the same, because sometimes I've seen this where you add more RAM and the optimizer make a different choice about the query plan, and which turns out to be bad. And all, of course, depends on how critical that you don't run into surprises in production.
I would argue that you should have maybe not the same number of CPUs, but at least I think it's 4 that you need to have present for a hash join to be able to run in parallel, or it won't be considered to run in parallel if you have less than 4 CPUs. So that's also a thing on the test box to at least make it possible for the optimizer to choose the same plans.
Yeah, that's also a good point, and because that hash join may be better for you when you run it in production, but it may also make a complete disastrous choice on the memory ground, and things go down the drain. The one case I remember was, so they tested it very carefully when they went from they had a plan with 332 megabytes of maximum memory. I think they had a hash operation, and then they went up to 336. And now the optimizer said, oh, I can do this thing with a sort, with merge or whatever, and introduce a sort. And that sort just built badly to disk. It was, yeah, quite hilarious, but you can run into these things. Also, some considerations about indexes. So if you're going to do these large operations, and if you have a machine to own, it's a great idea to disable non-clustered index you don't need for the chunking operation and rebuild them and to enable them later, because that can boost performance quite a bit, rather than having to maintain the index as you move on. Do that at the end. And the same applies also to foreign keys. And I don't remember if I tested this with check constraints, but foreign keys can absolutely also pay off. Now, could there be a reason to add index to support the chunking operation? And absolutely, I mean, you create the index once and you seek it many times. Could it even be the case that changing the clustered index is a good idea? Well, maybe, but it's a trade-off, of course, because you might speed up the chunking operation a lot, but then you're going to recreate that clustered index twice, and in the full recovery, that's going to be quite expensive to fill up the log. Although I like to remind you that SQL 2019 introduces a resumable index creation, and this is interesting. This is actually chunking behind the scenes. But again, these are things you will have to, if you have plenty of time in your hand, to test. You can find this out. Now, let's move. The last thing I like to talk about is to use chunking to handle errors. Sometimes all or nothing is not what we want. So what I mean by this? Well, let's say this. You're reading orders from a file, like 70,000 orders. And the thing is, this comes from a non-trusted source. So that could be, well, a product we no longer have, or a customer we have blacklisted, or just some, well, required data that is missing. So if we just try to read all these 70,000 orders in one single insert statement, well, that were 2 bad orders, and we lose all 70,000. And of course, we don't want to do that. Okay, so we have to run a loop and process one order at a time then? No. We can divide the orders into chunks. And if there is an error in one chunk, rewrite that one into smaller chunks and retry and so on. And eventually, few orders will have to be processed one by one, but not all of them. So let's have a look at this. So I'm going to start.
By the way, a perfect pattern for an ETL load if you use SSIS. Do like batch sizes of 1 million or something, and then in the error handler just skip the one row at a time and just output on the error list the one row that's missing, so you don't miss a whole chunk.
Yeah. So I'm going to start this script immediately, because this is the one that just doing a simple loop. I got some local variable here that when I started, how long time it's been running, a row count, and then I'm setting up a cursor from a table called new orders, where I have not really 70,000, something like 67,000 rows. And going to fetch the order ID, then I'm going to set up a try block here, start a transaction, insert the big orders and into big details. There's also a table called new details. I commit. And then I got a catch handler. If there's an error, I'm going to roll back the transaction, pick up the error message, and I'm going to raise an error here with no wait. And oops, yeah, this has already completed. And then I got some diagnostics here, so it's printing out for every 1,000 rows. And you can see it's again razor, but this now is level 0, but I use razor to go with no wait. And then at the end here, I'm printing out the final statement and then also doing delete so I can start over. Now let's see, how long time did this one take? Oh, this gets me worried because it's a bit too fast. 127 seconds. Well, the reason I get worried is that then maybe the other one was not going to be that much faster. We'll see. This is a chunky version anyway. So I got, well, this is all good for monitoring the execution. I got a chunk number. I got a table variable with chunk sizes to process, and this is a wee bit too many sizes to use really, but I want to have a couple of sizes mainly for the sake of the demo. So I'm going to try 2,000, then I'm going to fall down to 10, 100, and then to 10. And you don't see 1 here, and I'm going to explain why later on. And then I got a temp table with my chunks. This is a big temp table. I got it all order IDs here. When I fill it up again with order ID, row number, and integer division with the biggest chunk size for my table. And again, I got, well, the chunk size order, all the order IDs in contiguous. Now I'm going to loop over that table, so I don't have a cursor because this one is dynamic, and my entire full while block is begin try. So I get the smallest chunk number that I have, start my transaction, get the rows from this chunk here, select some temp orders, get the row count, and which I need for diagnostics reasons, and then also fill up in big details, and I'm printing out how many rows there are inserted in this chunks. Again, it's a razor with level 0, so it's not a real error. And then I'm going to delete that chunk that I processed from the temp table. Now, if I got an error, I fall down here in the cache block. I roll back the transaction. I see, okay, how big was the current chunk? And if the chunk size is bigger than 1, I'm going to go down to the next chunk size. So I say select max size from chunk sizes where size is less than chunk size. But if I get the smallest chunk size, or if I'm already there, I will get null back, and then I will get 0. Oh, sorry, get 1. And the reason I have 1 here, not in the temp table, is that, well, I need to have 1, so it's kind of silly. I have it in the table variable. Well, could have made some stupid mistake and forget it. And then I go again producing a diagnostic message, level 0. And then I will assign new chunk numbers. So what I do here is that I got a CT here, so your chunk number, and temp chunk is again row number, and divide integer division with a new chunk size, and for this chunk. And then you might think I need to join that CT back to the temp table. But I don't need to do that. I can update the CT directly. Yes, I know this looks scary the first time you see it, but it's very efficient. So I can just say chunk number equal temp chunk, and adding the max chunk number in the temp table. But if I had a chunk size of 1, I'm going to fall down here and say, I'm going to pick up the error message and the order ID, and then I'm going to say this is it's a real error. So let's see, and then of course I'm going to delete that chunk from the temp table. And then the final thing at the end, how long time it took, etc. Let's start this and see how it runs. Oops, it doesn't run at all because okay. And you can see here I got a redivision, so that was an error in that chunk. A redivision again. And they keep on running, and you get some errors at the end. And in total, it took, well, 9.5 seconds compared to, well, 27 seconds here. So not really a factor of 3, but almost. So it was quite a bit of an improvement. Now, one challenge with doing this is that how do I pick the initial chunk size? If you set the initial chunk size too high, well, then about every chunk will error out and roll back. And of course, that is not efficient. So here's my rule of thumb. And this is just based on common sense. There's absolutely no testing behind this. But if you expect one row out of n to error out, well, set the initial chunk size to n divided by 10. And of course, assuming no other limitations like having been nice to others, etc. Then again, of course, determining that n may require some good gut feeling. Well, if you already have an operation in place where you're doing 1 by 1 and you want to improve it this way, well, then you may be able to get some data to see how common errors are. And also, one thing to consider is, are the errors completely random, or do they come in bursts because maybe the source is having a bad day? Because if they come in bursts, then you might have a bigger chunk size than if initial chunk size than if they are completely random. And I would say that if you want to divide by chunks, go by at least a factor of 100 or maybe 1,000. I think we did this at one client a couple of years back. I wrote the spec, and another colleague, he implemented it, and he actually said, okay, I'm going to do 1,000 at a time, and if that fails, I'm going to fall back to do 1 at a time. And I think that worked out well. So we're coming towards the end of this session. I'd like to do a summary of what I've been talking about. So, I mean, this is nothing we do every day. It's a trick we have in our toolbox for the very large operations to keep transaction log and temp to be in check, and to avoid conflicts with the rest of the system. And make sure when you're doing these really large operations that you have transaction log backups running, and with a high frequency, because you will produce a lot of transaction log, chunking or not. And indexing is critical. Your chunking must always follow an index, preferably the clustered index, because repeating scans is extremely costly. The top method is a very generic way to drive chunks, and works with any data type you can put an index on, and it even works with non-unique indexes to some extent. If you have multi-column keys, will only work with that second level if you really have to, because you have to be very, very conservative about the chunk size. And defining chunks in the temp table is far less efficient than extending the top method, but it's just so much simpler. And don't forget to make interval variables known to the optimizer, either with option recompile or sniffable through dynamic SQL. And dynamic SQL may in some cases benefit from full scan statistics. And don't forget to consider how your applications will be affected if you, for some reason, the operation doesn't get all the way through. Design your loops so they can restart when they are interrupted. You may not actually have to implement or code that one, but at least you need to have a plan for it. Because, and if needed, create a help table to track where you were. And don't forget the test for correctness and for performance. So this is the last chunk. My name is Erland Sommarskog. My email address is sq@erlandsommarskog.se, and you're more than welcome to drop me a line if you have anything related to this session. Oh, yeah, by the way, I should say this. I have basically only scratched at the surface of this complex topic. I mean, as I said, this is nothing we do every day. So every time we do this, we learn something new. So if you have some revelation that you did, Yes, I would really like to hear about it. Slides and scripts for this session is available at sommarskog.se/present, and also the Big D database. Here's a download link. It's 3 GB in download, and it will expand to 20 GB when you install it, and you'll need at least 2016. So that was all that I had to say, but if there are any questions, I would more than gladly answer them.
There is one question from Marek. What would be a recommended way of chunking on a table that has a clustered column store index as the only index? Would you adjust the chunk boundaries to match the row groups so that only one row group at a time gets decompressed? Or something else?
Okay. To be honest, I have not worked with the custom column store index, so if I would try to answer that, I would probably say something silly. I don't know. I would have to test. Maybe in that case, it would be meaningful to add a non-clustered index to do the chunking. Because I mean, I'm thinking here. Yeah, okay. The row groups. Yeah, the row groups are. They have all the rows, but it's no. Maybe, but then you have to find out the row group boundaries are. That could be an idea. But I haven't. As I said, I haven't worked with it. I mean, I play with the column store index, but I've never used them in practice. So.
Oh, and I think it's gonna it depends, but I mean it's probably gonna depend on if the row groups are I don't remember the name. Is it aligned? Let's say, I mean, for a column, if you have all the 1s and 2s and 3s in one row group and all the 4s and 5s and 6s in the next row group, it's simple. But that requires kind of a sorting before creating the clustered column store index. And if you haven't done that, it's going to be mixed. So then it's hard to do it by boundaries, I think, at least. So
Yeah, no, I will have to. No, test. That's the only thing. You need to test this. And I said I haven't tried this myself. But of course, it's a valid question. Maybe I should do that. Well, I find some time.
I have Lars Rasmussen. How long have you been using BigDB database? I missed the beginning of the presentation.
For how long? Well, it's been used all through the examples in this session, and particularly all the tests. All the tests I've run is in BigDB. So most of these procedures, well, all these procedures are in BigDB, and there's quite a few more procedures that I haven't. Well, I haven't there is not too much documentation and description. I don't have the test script set up because the test script itself is a Perl script, but the procedures are there. And I mainly set up if anyone will have a big database to play with. If you have a bigger database at home that you can play with, that works out. That's okay. But if you wanted to have this one, you can try with this one. There are also a few more tables than this one were included in the session, but that I used to do some testing, and then I decided, okay, I let them be there.
Last question in the chat now is, and I think this is a case where some seniors have given some bad advice. Manish asks, usually when we do such chunking, I was told by my seniors to stop the transaction log backup for some time, and when we're done with the whole chunking task, we resume the transaction log backups. And I would say that is not a good practice.
No, that doesn't seem like a good idea. If you say that if you can afford to put the database in simple recovery or in bulk load recovery, well, yeah.
Oh, yeah.
So, yeah, particularly if I can say this, if you are in bulk load recovery, it could be a point of stopping the transaction log backups because a few operations are minute transaction log, because when you have a bulk load recovery, you're only you're only logging the extent allocations, and then when you take the backup, you're actually backing up the data. And I could see that maybe it could happen that particularly if you update rows more than once, that you will back up the same rows multiple times. And in that case, it might be better. But then again, they would be fully logged the second time, wouldn't they? Yeah. And bulk load recovery is a better choice than doing simple recovery, because you can still apply the transaction, or you can't do a transaction restore to point in time if you have done a mini load operation inside the log. But at least you can, because what could happen is this. you find out the next day that, oh, the database is corrupted. Oh, it has actually been corrupt for a week. So you want to restore the backup from a week ago and apply the transaction logs. And now if you switch to simple recovery, your log chain is broken and your host.
Yeah.
I'm definitely allergic for production database switching to simple recovery only for a short time, because you never know that you might need, if you need to reapply the transaction logs.
Lars says, I usually prefer to increase the frequency of transaction log backups when actually performing a atypically large load in production. And I would probably, I usually set it to 5 minutes anyway. So it's.
Yeah, that's what also I suggested, that you might have to do this, because you can't say, oh, I'm doing chunking, so the transaction log will not be an issue. Yeah, a lot can happen in 50 minutes.
The last words will be, thanks a lot, great high-speed presentation. And that's always the case with Erland's presentations.
Yes. So I have some kind of ambition. If I get a session evaluation saying it was too slow, then I know yes, but yeah, for some reason it doesn't happen, because I always crank too much material into my sessions. So, anyway, it was a very nice talking to you. I appreciate very much everyone who was there, and thanks to you, Magnus, for running this event. It was very nice.
See you.
See you.
Bye.